Surface area of the tent do not include the floor. So I need how many of these guys? Two? 4. And what is the area of that guy? X times x. So what is it? X squared. And there's 4 of them, right? So 4x squared. That's the walls, right? What's this guy? 5x over 8 times x. And how many of them are there? 2. So there's 2 times 5x over 8 times x, right? Okay. What's 2 times 5x? 10x. And 10x times x is 10x squared over 8, right? So that is the walls. Why didn't the squared show up? The walls and the roof, right? So the only thing missing is this triangle here, yeah? I'm going to draw that a little bigger because it's a little bit tricky. 5x over 8 and x. How do we find the area of that? You know one way to do it. But you also know another way from your last test, because there's a way to do that without finding the height. Some people will know that. Some people won't. If you don't find the height, then you got to use, I can't even remember the guy's name, but it uses all 3 sides, huh? Heron, yeah, that's it. Heron, there's a theorem that allows you to find the area of a triangle without finding that height. But you still got to do a square root of a fraction, so it's still difficult. I find it's easier just to do the square root of the height. If this whole thing is x, what's this? Just this part. X over 2, right? And that makes this a 90-degree triangle, right? Which means this right here, in green, has to be the square root of 5x over 8 squared minus x over 2 squared, right? Everyone agrees? Okay. So that is 25x squared over 64, yeah? Minus x squared over 4, right? We're still cool? Not quite, because we don't have the whole 4 there. And then all that needs to be square rooted, right? You have a few options here. Okay? 1, you could combine these right now in square root, right? That's what I do. If I was going to combine these, what do I have to do to that 4? If I'm going to combine 64ths and 4ths, what do I have to do? I got to multiply this by 16, right? So I get a common denominator. So I really need the square root of 9x squared, because 25 minus 16 is 9, over 64, right? Now, that is the same as the square root of 9x squared over the square root of 64, right? What's the square root of 64? 8. What's the square root of 9? 3. What's the square root of x squared? X. So it's 3x over 8. That's the height. Everybody cool? Now, can I find the area of the triangles? I need 2 of them. It's 1/2 base times height, right? So can I throw out the 1/2? Because I need 2 of them, yeah? So if this is the height, I just got to multiply that by the base, which is x, right? Which is 3x squared over 8. That is the green part. So I have now 4x squared plus 10x squared over 8 plus 3x squared over 8. Yes? If I want to add all them up, what do I need? Common denominator of what, Jalem? 8. I have 8 there, I have 8 there. Do either of those have to change? No. So I keep my 10x squared. I keep my 3x squared. What's this have to become? 32x squared. 32 plus 10 is 42, plus 3 is 45x squared over 8. That's the area. And I think that's what they wrote. Actually, I think they did something weird to it, slightly different. They wrote it differently. Oh, no, they didn't. I thought they did. And then finally, if the whole thing is 90, calculate x. So 45x squared over 8 equals the area, which is 90. And then we just do algebra. How do I get rid of the 8? Pardon? Multiply by 8 by 8. 45x squared is 720. How do I get rid of the 45? Divide by 45. X squared is whatever that is. 60? 16. Oh, it works out perfectly. Nice. And x equals 4. Okay? Okay. Now, again, I never ever showed you this, did I? But, do you all know how to square? Yeah. Do you all know how to square root? Yeah. Right? All of it makes sense if you just slow down and think about it. I didn't expect people to get this question particularly right. I just wanted to see what would happen. Since most of you were in my grade 9 honors class, you have seen all of this. I can't guarantee the other class, but my class has seen all of this. Okay, but you just said it made sense, so. All right, everybody good? Number 8. Oh, son of a gun. 8. Okay. What do we measure volume in? Cubes, right? Okay, what do we measure area in? Excellent. So, if I tell you that is 16 centimeters squared, how big is each side? It's a square, so how big is each side? 4, right? Square root. Okay. Why? If I tell you that's x and that's x, then it has to be x squared would have to equal 16, right? Then we'd square root. Okay. But now we have a cube. How do I find the volume of a cube? Right. But if it's a cube, the length and width and height, they're all what? Same. So it's x, 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 right? So what's the volume of that cube? X cubed equals, in this case, 5832. Well, when it was x squared, we used the square root, right? Well, what do you think we got to use here? Cube root. If you don't have it on your calculator, an actual button that says 3x, then you got to learn how to use your calculator. If you didn't know how to use your calculator, then all you would do is write cube root of 5832, and I'd be perfectly happy because then you know what you're doing. I haven't spent a lot of time talking about how to do a cube root on your calculator. We did in the first unit a bit because you almost never use it, right? Remember how at the beginning of the year when we were talking about pi, I said you'll stop using pi as anything but pi? Well, now you're going to stop doing square root of 45 you're never going to write that ever again as 6.7 or whatever it is on your calculator. You're never going to write it that way again. You're going to write it a different way. Okay? Everybody good? Yeah, all right. So we can go on? Or does nobody wish to talk about your contest from 2014 that I gave you the key for? Okay. You shouldn't be worried about it. It doesn't affect you in any way. It's like a lottery. You might win a $500 scholarship.
It's so hard.
But what if we don't want to win the scholarship? Do we still have to do the final?
Yes. All right. So, actually, Harmon just asked pretty much what the beginning of this lesson is about. So we're going to blow through this pretty quickly because you guys already know how to do this. How do I find the area of that rectangle? LW, right? Area equals LW. If it's a square is a special kind of rectangle, right? So I can still go LW, but what makes a square a square? All sides the same. So L and W don't need two different letters, do they? I can make them the same. X and X. So even though the area of a square is still technically LW, because L and W are the same, we write it as X squared. Everybody cool? If you're provided with the area of the square, how do you find the length of each side? Well, if area equals X squared, and I want the length of each side, that's X, right? I just do algebra. What do? How do I get rid of a square? I square root. And X equals the square root of the area. And X is the side length. That's why we call square roots square roots. That's where the name comes from. Because you get it by drawing a square. Everybody good? Concept? Everyone's fine? Sweet. The symbol, this symbol right here, which is not the square root symbol, do not call it that. It's the radical sign. When it's written like that, with something underneath it, so put an X under there, it's asking you to find 2 and only 2 equal factors of X. X has a special name. We'll get to that in a minute. Whatever number is under there. Whatever number is under there.
Underwear.
Dad joke Thursday.
That's the kid joke.
How do you think the kids heard that joke?
Kindergarten.
From their dads. Everything you have ever learned comes from somebody else. You don't just wake up in the morning, come out of your mom like, underwear. Yes, it is true.
I don't make money too. See? Original.
Right. So, Jalem has already explained to us how do we find the volume of a prism. LWH. Why is a cube a special prism? Because they're all the same. Why? So the area of a cube is still LWH, but or the volume of a cube, since LWH are the same, it's the same as y cubed. So if we're trying to find the side length, again, volume equals y cubed. You got rid of a square by doing a square root, so you get rid of a cube by doing a cube root. Now look at the difference. What's different between there and there? That little 3. We still have a number under here. We still have a number under here. The little 3 is asking me to find 3 equal factors of y, whatever y is. The small 3 is called the index number. Please highlight that, because we are going to be using it a lot. Whatever that number is, that's the group of factors we seek. So, anytime you see a number that, that means you're looking for that many factors. Except when there's no number there. When there's no number there, you're looking for 2. So a root is 2. Cube root, 3 factors. Fourth root, 4 factors. X root, X factors. Got it? Can't be a 1 root. How can you have 1 factor? Well, I'm asking you, how could you have, what is a factor?
A factor is something times, alright, yeah, a factor is something that goes into it, it would be the same number. It would be the 1 root.
Okay, dude,
The 1 root
Jalem.
is 10.
No, Jalem, look.
Genius.
2 times 3 equals 6. Where are the factors? Where are the factors?
Factors?
What are the factors in 2 times 3 equals 6?
3 and 2.
Right. Okay. So now it's not a factor until it multiplies by something, right?
Oh, that's what it is.
So what's that?
That's a 2.
Has it multiplied by anything?
No.
So it's not a factor.
Oh,
So could you have a 1 root? No, because you need at least 2 things to make factors.
yeah.
Picking up what I'm putting down?
Yeah.
Read my mail?
Make it up.
Mowing my lawn?
Say different things, not root. It's gonna be root. 1 root.
All right. A perfect square or a perfect cube is a number whose square root or cube root is rational. How's your boy?
He's doing all right.
He played yesterday. He played very well.
He said he made an incredible kick.
He did make an incredible kick.
He said, Myers said I did an incredible kick, and then I did my impersonation of you. And I was like, did it sound like that? He's like, yeah.
What do you need?
I'd like to talk to him about the skills trip next week.
You talk, brother.
Sweet.
Listen to Grell.
Hello, Mr. Grell. I am taking you, well, not me individually, but as a group, we're all going to the provincial skills competition next week, Wednesday. It is a trip that we do with the grade 10s every year. All the grade 10s in the city are going. And what provincial skills you're saying? Well, when you go to a basketball competition or a tournament, everybody's playing basketball. But when you go to provincial skills, everybody's competing in something different. So we have carpenters competing, we have plumbers competing, we have masons and landscape, horticulture design, we have cooks, we have auto body repair. There's just a ton of different trades, and everybody's that's competing on that day has actually qualified at a regional. So they've already got a gold medal from a regional competition, and now they're competing on the provincial scale. And believe it or not, if they win a gold medal at provincials, they go to nationals. This year, nationals are in Edmonton, and we've had students in the past go to nationals. In fact, we had a team from our broadcast and TV 2 years ago win nationals. And
Interviewing me.
yes. And they
In case
put it on
anyone
the
cares,
board.
it was an interview with me.
Are you too?
This is grade 9.
It was.
What?
Why are you laughing at me? It was an interview with
I'm
me.
laughing at you. I'm happy for you.
Lies.
So you do need to bring the forms back. The deadline for the forms is Monday. Bring the forms to Mr. Myers on Monday. Mr. Myers Monday. All right, and then I will get them from him along with a class list, and then I know who's brought me a form. Yeah,
So it's a have to go trip?
it's a yes.
You're missing one block. This one.
No, I'm asking.
Mr. Myers is going with us.
Which is the one.
I was gonna take him to Leslie's play.
I've heard that as well from someone else. Yeah, so there you go. Forms, Mr. Myers, Monday. We're all going. Awesome time. Thank you. Back up. Math.
Math, indeed.
Everywhere.
Yep, lots of alliteration in this class. All right. Listen to me. I know that a lot of you have lived through the current school system in Canada where memorization is viewed as an evil word. Those people are idiots. Memorization is absolutely essential to making your life easier in math class. And when I say memorization, I mean memorization. Like you automatically know how to turn your alarm clock off in the morning. You don't wake up every morning and go, beep, beep, beep,
I actually do.
and throw it at the wall. You reach over and you turn it off, right? You automatically know how to work an elevator. You don't walk into every elevator and go, and just stand there hoping somebody else comes in, right? Huh?
I was walking by and it was just like the other person in the elevator and he was just standing there and it wouldn't close. And he was like there for a minute.
Anyways.
I walked in and I was like, I'll just push it for you.
Okay. And you see how paralyzing this fear of memorization is. The first thing that died in the memorization, the quest against memorization was the times tables. They stopped making you guys memorize them. I don't know why, but they did. I know that they have stopped doing that because my kids are going through school right now and they are still doing this. 3, 6, 9, 12, 15, 18, 21, 24. 3 times 8 is 24. And I see some of you quietly counting 8, 16, 24, 32, 40. 8 times 6 is 48, Mr. Myers. And that's okay. It's not your fault. But believe me, if you were able to actually memorize your times tables and automatically knew 8 times 6 was 48, then your life in math would be easier. That is my first quest, to bring back the memorization of times tables. I will fail in that quest because the world in Canada is very worried that if you can't memorize, people will think you are unintelligent. And then they will say that memorization is a skill not related to intelligence, which is absolutely true. But that's like saying you can't memorize stuff when every single one of you knows how to kill the big boss in every video game you ever play because you have memorized it. Anyways, the next thing that you need to memorize after your times tables are at least this. The perfect squares from 0, the perfect natural number squares from 0 to 400. Memorize them. Then the perfect natural number cubes from 0 to 1,000. Memorize them. I know you did because Mr. Hirschman has heard me give this speech, and he knows how important it is. All of you should already know it. 0, 0, 1, 1, 4, 2, 3, 9, 5. Did I miss 4?
I don't know. Yeah.
4. Oh, I see what I did. I went the wrong way. 9, 3, 16, 4, 25, 5, 36, 6, 49, 7, 64, 8, 81, 9, and 110. Right? 121, 11. 144, 12. 69, 13. 196, 14. 216. Wait, I missed one. 225, 15. Now I've lost my train of thought. 256, 16. 280. 289, 17. 324, 18. 361, 19. 420. Now, there is a pattern, as you can see. You added 1, you added 3, you added 5, you added 7, you added 9, you added 11, you added 13, you added 15. This last one you added 39, so what's the next one going to be? 441, and that would be 21, right? Then you would add 43, 484, that would be 22, and so on. But know those. I cannot stress it enough. Your next 3 years of math will be so much easier if you have your times tables memorized and these two things memorized. Okay? I'm going to give you a third thing to memorize today as well. List the perfect cubes. Same deal. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And 10 cubed is 1,000. So helpful. Cannot stress it enough. Learn them, live them, love them. Why did I specify natural number cubes right after I talked about perfect squares and perfect cubes? And I didn't say natural, I said rational. What's the difference? We usually talk about perfect squares work out perfectly. Yes? Right? But there are other numbers that have square roots. Right? For example, the square root of 3 is a square root, but it's irrational, isn't it? It's 1.732, blah, 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 blah. Right? But, and the square root of 36 is 6, yeah? What then would be the square root of 0.36? 0.06? 0.6. You with me? So 0.36 is still a perfect square, but it's not on our list. Does everybody understand what I mean? But because we know how to deal with these, we can figure out this. Gouda? Great. Now, you people aren't as guilty of this as most of the other classes I teach, what we're about to do. But you are still guilty of it. Because every so often, you hand me in work with impossible answers. Right? Like sometimes when you're doing trig, you tell me one of the sides is longer than the hypotenuse. You still make those kind of mistakes. Right? And how do I tell you to avoid those kind of mistakes? Estimate first. Before you touch your calculator, before you do anything, estimate, right? So once again, we're going to do some estimation. I am asking you for the square root of 72. Let's look on our list. Does 72 have a square root? Does it? No, because it would be right there, yes? So, all of you should have seen this before, but I'm going to re-explain it anyway. 64, 81. 72 lies right in the middle, yeah? What's the square root of 64? 8. What's the square root of 81? 9. So the square root of 72 must be right in the middle, yeah? How far is that on the number line? 17. How far is that on the number line? 8. So I have gone 8 out of a possible 17 steps in here, right? And the whole number was 8. Now, 8 over 17 is a yucky fraction, but it's pretty darn close to what? 8.5, isn't it? So our guess here is 8.5. If you were to get out your calculator and you were to do the square root of 72, you would find it was 8.48. What was our guess? 8.5. What would you round 8.48 off to? 8.5. Everybody picking up what I'm putting down? Sweet. Do the next 5. Without a calculator. That's not fair. I'll do one more. I'm not a meanie. 180 is between what and what? 13 and 14, right? 13 is 169. 14 is 196. How far is that? I think you know. 27. How far is 169 to 180? So I have 13 and 11 out of 27, yes? That's pretty darn close to what? Isn't that pretty close to 10 out of 30? So 13.33, 1/3. Now we can check. Square root 180, 13.4, 13.33. Easy peasy, right? Now you should be able to handle the rest by yourself. Meanwhile, I'll be writing down all 4 of these. Now, why is E tricky? The numbers are pretty big, right? If we're working it in our head. But we're only estimating, aren't we? So isn't that pretty close to 340 to 510? Right? Which is 170, right? And that is pretty close. That is 65, right? 65 out of 170. We could go ahead and say that's 6 out of 17, couldn't we? Which is basically a third, isn't it? So we could say that's 7.33. Everybody with me? And for 176, we'll just finish it off. It's between what and what? 125, which is 5. 6, 216. I shouldn't have written it that way. 216, 6. That is 90, right? Essentially, right? And that is 50, right? So it's 5 and 50 over 90, which is 5 over 9, right? Which is a tiny bit past half, right? So what about 5.51? Everybody cool? It's easy peasy, right? Okay. Your work for today is 118, 119, and 120. Now, on 118, all I want you to do is follow the instructions. On 119, I want you to see if you can figure out a way to estimate without using your calculator. See if you can figure it out. Follow the instructions, but if it's irrational, or you think it's irrational, find a way to estimate it. Okay? Find a way. Figure it out. Okay? What's the easiest way to tell if it's irrational or not? Right, so you can use your calculator to check that. Now you already know this one isn't going to work, right? Because it's not on our perfect square list, yeah? So you would be figuring out a way to estimate that one. Picking up what I'm putting down? Read my mail, mow my lawn? So you can check them with a calculator, but then I want you to try and figure out a way to estimate it. Okay? Try to avoid your calculator usage. And you have, 15 minutes to work on that, and then we're writing our contest. Okay? Marley, of course you can.
Do all teachers know about this field trip?
Yes.
Because like, just wondering if we would have to tell our.
No, you'll be back by lunch, by the end of lunch.
Yeah, that'd be pretty tough. It's like after.
Yeah. You'll be back for your Block C class. You're only missing one class, mine. Which is a pain because I was going to take you to see the play that Miss Kemp's students are putting on. It's during this block on the same day. But what are you going to do? If you are there any grade 9s in here? You two obviously don't go on that trip, then you gotta find somewhere else to be. I'll probably just send you next door to Mr. DeVries.